Hello everyone! Today we are going to explore a topic that sometimes gets a reputation for being difficult, trigonometry. But I want to show you it's understandable and incredibly useful. You might think it's just for advanced math students or scientists, but the truth is, its ideas are all around us. It helps us understand the world in terms of angles, distances, heights, from the way a video game character moves across a screen to the construction of a towering skyscraper. It's a tool for measuring things we can't easily reach, the height of a tree, the distance to a star. Many people feel anxiety when they hear trigonometry. They picture complex formulas and strange symbols. My goal is to break down those barriers and reveal the simple, elegant ideas. We'll start with something familiar, the triangle. Specifically, a special kind of triangle that holds the key. We will build understanding one small, logical step at a time. Everything we are going to learn today begins with a special shape called a right triangle. A right triangle is any triangle that has one angle that measures exactly 90 degrees. This 90-degree angle is often called a right angle. It looks like the corner of a square or a book. This special corner is the foundation of trigonometry because it gives us a point of certainty. The other two angles in a right triangle will always be sharp or acute. That means they are both less than 90 degrees. This simple, rigid structure is what makes the right triangle predictable and useful. Let's get familiar with the names of the sides. The side directly opposite the 90-degree angle is always the longest side. We give it a special name, the hypotenuse. The other two sides are called the legs. In trigonometry, we give those legs more specific names depending on which acute angle we pick. From this angle's point of view, the two legs have roles. The leg directly across from our angle is called the opposite side. It's the side that our angle sees. The other leg, the one next to the angle and forming it, is the adjacent side. Adjacent just means next to. The hypotenuse always keeps its name. It's the longest side opposite the right angle. Remember, opposite and adjacent depend on which acute angle you choose. Switch to the other acute angle, and the opposite becomes adjacent, and adjacent becomes opposite. Take a moment to visualize this. See the triangle, pick an angle, and identify opposite and adjacent. This is the bedrock on which we will build everything else. Now that we understand the parts of a right triangle, the hypotenuse, the opposite side, the adjacent side, we can introduce the three main stars of trigonometry. Their names are sine, cosine, tangent. These might sound complicated, abstract words, but they are not. They are simply names for three specific ratios of the side lengths of a right triangle. A ratio is just one number divided by another, a simple fraction. The sine of an angle, often abbreviated as sin, is the ratio of the length of the opposite side to the length of the hypotenuse. Opposite over hypotenuse. Next, we have the cosine of an angle, abbreviated as cos. The cosine is the ratio of the length of the adjacent side to the length of the hypotenuse. Adjacent over hypotenuse. Finally, the tangent of an angle, abbreviated as tan, is the ratio of the length of the opposite side to the length of the adjacent side, opposite over adjacent. Notice that the tangent function does not involve the hypotenuse at all. It only uses the two legs of the right triangle. To find the tangent of an angle, you divide the opposite side's length by the adjacent side's length. These three ratios, sine, cosine, and tangent, are called the primary trigonometric functions. They are the fundamental tools that allow us to relate angles to side lengths in right triangles. Let's define them one by one and then learn a simple way to remember them. These are just names for simple fractions built from the triangle's sides. We have now defined our three trigonometric functions: sine, cosine, tangent. That's a bit of information to hold in your head. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Trying to remember which ratio goes with which function can be tricky at first. Luckily, there is a famous mnemonic device that makes it incredibly easy to remember these relationships. It is the simple phrase, SOHCAHTOA. SOH, S stands for sine, O stands for opposite, H stands for hypotenuse. KH, C stands for cosine, A stands for adjacent, H stands for hypotenuse. TOA, T stands for tangent, O stands for opposite, A stands for adjacent. SOH reminds you that sine equals opposite over hypotenuse. CAH reminds you that cosine equals adjacent over hypotenuse. TOA, tangent equals opposite over adjacent. With SOH, KH, TOA, you have all three primary ratios memorized. Say it out loud a few times. SOHCAHTOA. It sounds like a chant, but it's one of the most effective memory tools in math. It will be your best friend as you begin solving problems. Use SOHCAHTOA to set up the ratios when you practice. Next, we'll put these into practice with an example. Now that we know our definitions and have our memory aid, SOHCAHTOA, let's put it all into practice. This is where trigonometry starts to become a powerful tool. Imagine we have a right triangle. We know the size of one of the acute angles, 30 degrees, and we know the length of one of the sides. Let's say the hypotenuse is 10 meters long. We want to find the length of the side opposite the 30-degree angle. First, identify what we know and what we want to find. Angle equals sine 30 degrees, hypotenuse equals sine 10m, unknown equals sine opposite side. We are dealing with the opposite side and the hypotenuse that points to SOH. Which part of the phrase uses opposite and hypotenuse? SOH, sine. So set up sin 30 degrees equals sine opposite hypotenuse. Plug in the known values, sin 30 degrees equals sine op 10. Multiply both sides by 10 to isolate the opposite side. Op equals sine 10 sin 30 degrees. Use a scientific calculator. Sin 30 degrees equals sine 0.5. So op equals sine 10 times 0.5. That means the opposite side is 5 meters. Just like that, by using one angle and one side, we found another side. This is the basic workflow. Identify knowns and unknowns. Choose SOH/KAH/TOA, set up the ratio, plug in values, use a calculator. Practice makes this second nature. So far, we've talked about trigonometry in right triangles. A great start, but limited to angles under 90 degrees. The triangle's acute angles must be between 0 and 90 degrees, but angles can be much larger. 120 degrees, 270 degrees, or even full rotations. To handle larger angles, we use the unit circle, a circle of radius 1 centered at the origin of an xy coordinate plane. Draw an angle from the positive x-axis and draw the radius to the circle edge at that angle. The radius length is 1. Drop a perpendicular to the x-axis. We form a right triangle inside the circle. The horizontal leg equals the x-coordinate. The vertical leg equals the y-coordinate of the point on the circle. This lets us connect any angle to x and y coordinates, extending trig beyond small triangles. From here, we can map the circle to sine and cosine graphs, a powerful redefinition. As the point moves, coordinates change smoothly, and so do sine and cosine values. This handles all angles. Sin, 90 degrees, equals sine 1 at the top, 0, 1, cos, 180 degrees, equals sine minus 1 at left, minus 1, 0. So sine and cosine are just y and x coordinates on the unit circle. Tangent becomes y divided by x. Equivalently, tan theta equals sine sin theta, cos theta. This identity follows directly from the unit circle construction. With this expanded view, trigonometric functions apply to rotations, oscillations, and many real-world systems. Next, we'll look at applications. Now we connect the unit circle back to sine, cosine, and tangent. Remember, on the unit circle, cosine equals the x-coordinate, sine equals the y-coordinate. Since the hypotenuse is 1, cos theta equals sine adjacent, hypotenuse equals sine x divided 1 equals x. So cosine of any angle is simply the x-coordinate at that point on the circle. Likewise, sine A is the vertical leg. Sin theta equals sine y divided 1 equals y. Sine A gives the y-coordinate for any angle. Every point on the circle can be written as cos theta, sin theta. This perspective frees us from the triangle-only view and handles angles of any size. For example, sin, 90 degrees, equals sine 1 because the top point is 0, 1. And cos, 180 degrees, equals sine minus 1 because the left point is minus 1, 0. Tangent, originally opposite over adjacent, becomes y divided by x on the unit circle. Tan theta equals sine sin theta, cos theta. This identity is always true and useful in many proofs and calculations. This expanded view is foundational in physics, engineering, and computer graphics, places where rotation and oscillation matter. Sine and cosine describe oscillations and rotations everywhere around us. Next, let's look beyond the classroom at practical applications where trig really shines. You might be thinking, triangles and circles are interesting, but how is this used in the real world? The applications of trigonometry are vast and everywhere. One classic example, architecture and construction. Designers need exact angles and lengths. Surveyors measure angles and distances on a site to form accurate plans. Navigation relies on trig. Sailors use stars and the sun, and modern GPS uses timing and triangles. GPS forms giant triangles between you and satellites and uses signal timing to compute position. Trigonometry is also at the heart of entertainment. Game programmers use it constantly. It controls camera angles, character movement, and smooth rotations. If you calculate projectile trajectories, like a thrown ball or an arrow, Trig helps predict the arc. In 3D graphics, Trig figures how light bounces to create realistic shadows and reflections. Astronomy uses Trig on a cosmic scale. To find distances to nearby stars, astronomers use parallax. Measuring tiny angle changes between observations 6 months apart and using Earth's baseline gives huge distances. From roofs to GPS to game engines and the cosmos, trigonometry is essential. It's not just abstract math, it's practical and powerful. If you practice, fluency comes with use. Draw triangles, label sides, use SOHCAHTOA, and a calculator for computations. The more you work, the more intuitive it becomes. Today we have taken a journey from the simple corners of a right triangle to the sweeping arc of the unit circle and out into the real world. We demystified trigonometry. It is a logical tool for angles and lengths. We learned the vocabulary: opposite, adjacent, hypotenuse. We met the 3 main functions: sine, cosine, tangent, simple ratios of those sides. We learned SOHCAHTOA to memorize them. Draw triangles, label sides, write the ratios. Use a calculator when needed to solve for missing sides or angles. Practice regularly. The more you work, the more intuitive it becomes. Don't just memorize, understand why it works and revisit the unit circle. You have unlocked core concepts of trigonometry. Keep asking questions, stay curious, and you will succeed. Good work today. Explore further and apply these tools.